नमस्कार दोस्तों, आप सबका स्वागत है टीपीएम अवेयरनेस सेशन। आज हम डिस्कस करेंगे के लॉस नंबर 6, रिड्यूस स्पीड लॉस। What is meant by speed loss? Reduced speed loss happens when a machine runs slower than its designed or ideal cycle speed, even though it is not stopped. Machine is running but not at full capacity, result hidden productivity loss. OE linked performance loss. This loss directly impacts performance efficiency in OE. Performance is equal to ideal cycle time into total output divided by operating time. If speed reduces, output reduces, which also reduces the performance. Typical examples: Shopfloor reality, CNC running at lower feed rate, assembly line slowed due to operator fatigue, machine running at 70 to 80% speed to avoid defects, hydraulic or pneumatic system pressure not optimal, old machine running below rated RPM. Major causes of speed losses. First, machine related. Wear and tear like bearing, guide, spindle, poor lubrication, misalignment, vibration issues, hydraulic/pneumatic system pressure not optimal. Second one is process related like incorrect parameter, speed, feed, pressure, non-standard setting between shifts, suboptimal cycle design. Then third one is material related, variation in raw material quality, high hardness, thickness variation, poor surface finish. For human related, operator intentionally reducing speed, lack of training, fear of breakdown or rejection. People impact speed, speed impact performance. To reduce this, train, motivate and empower the people. Then next one is maintenance related issues, weak preventive maintenance, temporary fixes instead of root causes. Strong maintenance is equal to stable speed is equal to better performance. Next one is speed loss. How to identify speed loss? First one is compare actual versus ideal cycle time versus actual cycle time, machine related RPM versus actual RPM. Use data like PLC, SCADA data, OE reports, cycle time study, trend analysis like shift wise speed variation, operator wise comparison. How to calculate speed loss? So this is one of the example. Ideal cycle time is equal to 10 seconds, actual cycle time is equal to 13 seconds. As per the speed loss formula, speed loss percentage is equal to actual minus ideal against actual into 100. So speed loss is equal to 30% loss in this case. How to reduce speed loss? First one is standardization, fix optimal parameters, display SOP at machine, lock setting wherever possible. Second one is root cause analysis, use YY analysis, fishbone diagram, don't accept machine old as a reason. Standardize, analyze, improve and sustain. Next one, autonomous maintenance, cleaning, lubrication, inspection, restore basic conditions, Kaizen activities, cycle time reduction projects, line balancing, tool optimization, small changes gives the big impacts. Real-time monitoring like end-on systems, speed tracking dashboard. Focus, improve and sustain. Skill development. Train operators on ideal speed importance, parameter control, quick troubleshooting. Skilled operator is equal to stable speed. Preventive and predictive maintenance, vibration analysis, oil analysis, condition monitoring. Train, prevent, monitor and improve. How to reduce speed loss? Key insights. Most companies ignore speed loss because machine is running, but small speed drop is equal to huge daily losses. Example, 10% speed loss is equal to 10% production loss. Over 1 year is equal to massive cost impact. How to reduce speed loss? TPM approach. Top TPM companies treat speed loss like a major breakdown, monitor cycle time every shift, review in daily TPM meetings, link to OE dashboard. In summary, machine running is not equal to productive. Speed loss is a hidden factory killer, directly affects OE performance, needs data plus discipline plus TPM culture, protect speed, protect OE, protect profits. If you found this video useful, please like, comment and subscribe this channel for more TPM and OE tips. Next video, KK pillar loss number 7, defect and rework loss. Thank you. We'll meet again.